Hi guys, I hope you're well. This is very weird, but obviously I can't teach you, so I thought I'll try and do a video and see if that helps you along a little bit. We're going to be looking at mechanisms. Ideally, obviously I would like to teach you this face to face, but I think it might help a little bit with some explanations in this video that go along with the PowerPoints in your booklet. Just to clarify some things, or there's certain things that are quite similar and it might just help to have an explanation to explain the differences between the two. So mechanisms is one of the things that could come up in your exam. It's come up last year. It will always be obviously in question 1 to 5 of the exam. Last year there was about 3 or 4 marks dedicated to it, so it's not a huge part of the exam, but obviously for those people heading for like grade 6 and above, it's crucial marks for you in order to get your marks to get your grade. There are some calculations that go with it, so there is some maths. I'm not going to cover those in this PowerPoint because I think that's something that I'm probably better covering with you when you're back at school, because it is the trickier side of the maths. And I think when I spoke to maths teachers in school, they were saying it's kind of top grade 6 maths. So obviously I would rather be covering that with you face to face than any issues we can pick up there and then, one to one, and what have you. So I'm going to try and follow along with the PowerPoint slides in the booklet, but I have missed a few out because some are just showing examples and things. And if I can, I'm going to try and put the PowerPoint slide on the screen as I'm explaining it when I edit the video. I don't know how to do this. I'm going to have to watch a YouTube video on how to make this YouTube video. So, fingers crossed, we'll see how it goes. If it's pants, I won't do another one, okay? Right then, mechanisms. I'm going to keep looking at my phone because I've got the PowerPoint on my phone and I'm also trying to look at the screen. So, multitasking at its best, guys. Okay then, so if we have a quick look, the slides in your booklet, so your year 10 theory booklet, the one with the red cover on it, if you find the mechanisms PowerPoint, I'm just, like I said, I'm going to work through those. So first slide is all about functions of mechanisms. So the first thing you've got to kind of realise about a mechanism is it's how something works. It might be a combination of things, it might be one singular thing, but a mechanism is kind of making something move. It involves motion, movement, and it's found in like a lot of things, a lot of everyday items that you're using. You'll be using mechanisms without realising, okay? So movement and motion bring products to life. So if you've got, I don't know, like a can opener, for example, you're opening a tin. If you're twisting the handle on that, you're creating a movement which is making it work, okay? So like it says on the PowerPoint, every basic product relies on movement for its operation. In some cases, parts of the product move, and in others, the entire product might move. So it is just dependent whether it's kind of you are creating one type of motion, which we'll look at in a minute, or whether you want to create a combination, because what some mechanisms do is they will change one type of motion into another one for us, okay? So some of these motions might be really visible. So if you've got a fan, it's when I'm filming this at Easter, it's quite warm. You might have fans in the home that are moving around to circulate the air. You've got the fan rotating in the middle. That is moving, okay? It might be something that's internal. So if you've put something like a DVD in a DVD player, that is spinning around inside. We know it's happening, but we can't actually see it. So it's just some are visible, some aren't, okay? Dead simple stuff. Right, I had to cut a little bit out there because I went wrong. We're going to talk about the key terms, sorry, not the 4 types of mechanism. So there's some key terms that you will need to know. So when I talk about motion, I'm talking about something that's moving, okay? Obviously, I would hope that you would know that anyway, but if I'm talking about motion, I'm talking about creating some form of movement. A force can be a combination of things. So a force really is, you can apply a force, you can push something together, you can pull something apart. So that pulling force is classed, when I talk about force, it could be pulling. It could also be kind of a twisting force. If you're twisting a bottle lid off, you are creating a force on that to twist that bottle lid off, so it comes off of the bottle, obviously, so you can drink it. If I talk about a mechanism is a series of parts that work together. So I might talk about in this video something called a lever. That is part of a mechanism. So a mechanism, really, you've got to kind of get used to the idea that a mechanism is a combination of things together that make something work. And a mechanism can produce a force and a motion, okay? So these kind of key terms will be coming up as we go through. Then we've got a key term called a mechanical system. So a mechanical system is slightly different in that it takes a force and it produces another force as its output. It's to do with input and output, so I will be covering that with you as well. So these key terms will be coming up, we'll be going over them. You are going to have to know them, especially if you're answering exam questions, because actually if you're using these key terms in exam questions and perhaps you don't quite get the answer correct, but you are showing the examiner that you know these key terms and you've got some understanding of them, you could still get marks. So don't just kind of dismiss it and think, oh, I can explain it in my own words. You must be using the vocabulary, okay? So if we move on to the next slide then, and we'll go and look at, first of all, mechanisms and motion, okay? So like I said, mechanism produces movement. There are 4 types of movements, motions, that we need to know about, okay? So whatever movement is produced by a mechanism, it will produce one of these 4 things. So first one is dead easy, okay? On the actual PowerPoint slide, this car moved backwards and forwards, but because I've had to screenshot it doesn't, but you get the idea. A linear motion is literally just going in a straight line. So if you were moving across, a car was going down the road, it's going in a straight line in one direction, okay? So that's the easiest one, really. Linear motion in a straight line, okay? Don't think that is kind of reversing back. It is only simply going in the same direction. You then got rotary motion, which is going round and round, so it's in a continuous loop. So if you think of a wheel on a bicycle, although you are travelling linear, the wheel on your bicycle is turning rotary, so it's constantly going round and round in order to produce a motion. It obviously can stop, but there are plenty of uses for, like, there's plenty of products that will use the rotary motion. So if you think of a watch with a proper face on it, the hands are going round constantly in a continuous rotary motion, okay? The next one, the next 2 are probably the trickiest to remember and to spell. So we've got reciprocating, okay? So reciprocating is kind of like linear in that you're going in one direction, but what reciprocating does is it returns in the direction that it came from. So it's a backwards and forwards motion in a straight line. So if you think of using a saw, if you've used a saw in resistant materials with Mr. Barker, for example, you're using that saw, you're pulling it backwards and forwards, you're creating a reciprocating motion. Sewing machine needle, when you've been in textiles, that sewing machine needle's going constantly up and down, so you're creating that motion, okay? Then the next one is oscillating, okay? So oscillating is going backwards and forwards as well, but rather than going in a straight line, it almost swings. It kind of follows the circular rotary motion of something, but it swings from side to side. So it might be a pendulum, for example, on a clock. If you've got like a grandfather clock with a pendulum hanging down, that will swing from side to side with like the seconds to symbolise the seconds of the clock, okay? Some of you, again, I talk about fans, might have fans in the home that rotate round on the spot. That motion that, get in the camera, that motion that they create is oscillating because it's going round in more or less like a circular shape. It just only goes halfway and then returns back again. So anything that we're talking about in terms of mechanisms going forward, we'll speak about these 4 types of motion. So this is kind of like your basic mechanisms knowledge. If you don't understand this bit, you will find it very hard to understand the rest. So this is kind of your core knowledge, okay? So with that in mind, moving on, obviously you can pause this video and be answering the questions as we go along. I don't have enough technology to have everything in front of me, so hopefully you'll be able to kind of keep stopping and starting the video and keep going back and having a look at things. So obviously we've just covered there. We've got, to recap, we've looked at some key terms, we've looked at 4 different types of mechanisms. So you've start again. 4 different types of motion, sorry. So we've got linear, rotary, reciprocating, and oscillating. Okay, so on the screen at the minute, hopefully, you will be seeing 6 different products, and from that we can look and see which types of motion they create. So if we look at the top left, we've got a Ferris wheel. Okay, so if you're sitting on a Ferris wheel and you are constantly going round and round in a continuous circle, I would hope now that you'd understand that you are creating rotary motion. Okay, you've got a sewing machine in the top middle there. Like I was saying before, the needle on that is going up and down, up and down. So from that, you should be creating a reciprocating motion. If you are sat on a swing, if you think you're sat on a swing and you're swinging backwards and forwards, that swing's not going in a straight line, is it? It's actually curving. So when you're going up and back again, you're creating oscillating there. Okay. You've got the saw. So again, backwards and forwards. That is again reciprocating motion. The bicycle's a bit of a funny one, because the bicycle you actually can get two types of motion on. You've got the wheels that are going round and round, which give you rotary, and then you've got the travelling forwards in one direction, which is going to give you linear. And then again, just to kind of reiterate the difference between oscillating and reciprocating, you've got the pendulum swinging. Okay, so hopefully that kind of summarises a little bit the different types of motion for you, and I'm hoping that you're kind of following along and you can understand at this point. Okay, so moving on then, we are going to look at mechanical systems. So it kind of follows on quite nicely because the mechanical systems use these types of motion. So mechanical systems. Oh, my phone's gone funny. Right, so a mechanical system will take an input force or motion, because the two kind of very similar, and process it to produce a desired output force or output motion. So if you're inputting something in, it's the action that you are doing to start the process off, starting the mechanism off. Okay, the output force or motion is the result that you get from it. Okay, so if you were to ride a bike, the input force that you are putting in or motion, you are pedaling on that bicycle. So what that is doing, you are inputting a rotary motion, which is then making the bicycle wheels turn rotary, but the resulting output is you actually want to move forward. So what you get as a result of that mechanical system is you're putting rotary motion into the bike in order to result in linear motion moving forward. So what a mechanical system does, it will help kind of change that force, or in some cases enhance that force. It might make it stronger for you. It might make something work more effectively and efficiently. So you've got to kind of consider forces and motions together, mainly because a force, you are applying that force, but that force ultimately results in a motion. So the two do go a little bit hand in hand. Okay, so we're going to use the example here of some scissors. In fact, I'm going to pause the video and go and get you some scissors.